Hello everyone, welcome to our highway design masterclass. Today I will be taking you through the process of how to design road with Autodesk Civil 3D. My name is Engineer Andy Freke and I will be your host. Okay, in our highway design masterclass using Civil 3D, let's look at our course outline. In step one, we will look at how you can understand and interpret survey data. Then we will move to editing and setting of Civil 3D workspace. Then at step three, we will look at how we can import and arrange survey coordinate, talking about survey data. Then in step four, we will create horizontal alignment, adjusting of design curve to meet up minimum code requirement. In step five, we will create existing ground surface. Then step six, we will create vertical profile. In step seven, we will create design profile from profile creation tool. Step eight, we will set our band to reflect existing ground level, finish road level, design road level, invert level, invert drain level, and chain edges. In step in step 9 or step 8, we will look at how to create assembly, lane, shoulder trenches. Step 9, we will look at how we can create corridor. Step 10, we will create corridor surveys from horizontal alignment. And step 11, we will create feature line from horizontal alignment. Then step 12, we will create finish road level from create profile corridor, talking about the center line. In step 13, we will create sample line. Step 14, we will create material volume. Then step 15, we will create road cross section. In step in step 16, we will step 16, step 15, we will create road section. Then step 16, we will create frames and sheet. In our step 17, we will look at how we can arrange our drawings. Then in step 18, we will consider a comprehensive detailing of the road to reflect road monuments and features. Then in our final step, which is the step 19, plot, we will carry out the final plotting of the drawing. So it's going to be a very huge and an interesting class. So I want you to sit tight as we proceed with our design class. So understanding and interpreting survey data. So let's just move straight to that. Okay, so this is a typical survey data that has been given to us by surveyor, and this is the coordinate. This is the northern, this is the eastern, and this is the elevation, and this is the road the description. Now, before you can really understand what I'm trying to say, let's look at what coordinate are. What are coordinates? Coordinates are numbers that define a point in a particular location. A coordinate system is a method of identifying the location of a point on Earth. So from this definition, you know that as a highway engineer, that before you can actually locate a road, a road alignment, that you make use of coordinates. And coordinates are those numbers that define a point in a particular location. Then we also look at the coordinate system. The coordinate system is the source for obtaining the precise survey data. Now, coordinates are necessary when laying project out, whether it is a highway, bridge, site, work, utility, or another type of construction project. So, highway help you to help you to obtain a precise location of a particular features or a particular structural element. For instance, if it is a highway that you want, maybe you want to site a highway, maybe you want to site a bridge, you want to site any other construction projects. So it is the coordinate system that you will use to to locate a precise location of that features on the earth. Now, survey data are arranged in this way, in this order. Talking about the P here has to do with point. The P here has to do with point. So let's go back to our design data. This is the point. These are the point number. These are the point number. Okay. Then followed by eastern. Then the next is northern. Then the Z here is elevation and D here is description. Now, maybe for instance, a surveyor just submit this survey to you as a highway engineer. It is your responsibility to be able to arrange the survey data in the right order. So the right order in which will give you the right road alignment is to arrange this in the PENZD order, which is the point, the eastern, the northern, the elevation, and the description. So here we can rearrange this survey data. Now we have the PENZD talking about the point, the eastern, the northern, the elevation, and the description. Now, when we are talking about elevation, we are talking about the height, the spot height, the height of that road from the sea level, the height of that road from the sea level. So we are going to rearrange this survey data. Okay, so what we need to do now is for us to create another column. Okay, I think this is a column. So we are going to copy this, copy this. Okay, so from here we can delete that out. We can even remove that. Okay, so now we have we have our point number, we have the eastern, we have the northern, we have the elevation, and we have the description. Now these are description that define the survey or the features along the road alignment. Like what this RD simply means is road. There is an adjoining road. So the surveyor used this to describe an adjoining road and use the C here represents center line. There are some surveyors that use CL, but this surveyor decided to use C to represent the center line. And let me look at, okay, then we have this ZV. ZV simply means culvert. So if you see CV, it means culvert. This RD2 simply means adjoining road 2. So there's an adjoining road along the main road alignment. Then this means the TRM here means transformer. So along this road, there is a transformer by the side of the road alignment. So you should be able to study this description and understand in a situation where you can't understand the description, just feel free to call the surveyor. He will be in the best position to tell you the meaning of some of the description, because uh, these descriptions are not static. They varies depending on what is depending on what each surveyor want, depending on how each surveyor want to name his description. Okay, there's something I want to also point out here. Let me check if I will see that this CRD represent cross drain, cross drain, cross drain, represent cross drain. Okay, okay, this is something I wanted to really explain. Now, this CTL2, CTL3, and CTLO1 simply means control. They are temporary benchmark. Now, this is a point where all or maybe when you want to set out the road, you have to locate this control. You have to locate this control. You have to know the eastern. In fact, you have to know the coordinates of each of the countries. This is where the setting out of your road commence. So without this control, sometimes it might be difficult for you to set out the road alignment. So it is very important that when, as a highway engineer, when you are asking a surveyor to go and survey a road for you, and you need to tell him that he has to establish temporary benchmark, or what we also call control. Okay, so you can import this to Civil 3D Direct, or you can use this CSV. CSV. So I don't want to use this survey data direct. I want to I want to um, I want to change it to CSV format. So what do I do? What I'm going to do is that I will copy the whole of this. I will copy the whole of this information, and go to Notepad and paste it on the Notepad. So just observe what I'm doing. Just observe what I'm doing. Just observe what I'm doing. So I'm going to copy this. Okay. So click on copy. Then I will look for Notepad. So you can type Notepad. Okay. So this is the Notepad. So you click on New tab. Click on New tab. Click on Paste. Okay. So the next thing is for us to save this. So you click on File. You click on Save As. So I want to look for a new. I want to save this in a particular folder or in a particular location. So let's locate that location. Let's locate that location. So I have highway online training document. So this is where I want this to locate. Okay, so this particular road is called a Sana. So I will just write a Sana data for training. Sana data for training. Okay, so I will save it. Okay, I've done that. Okay, so I can close I can close the Excel, and then let's open our Civil 3D. Now, when you want to open Civil 3D in on the desktop, you have two version of Civil 3D, the one that has to do with Imperial and that of the matrix. So we are making use of the matrix. So you click on matrix. So you wait for it to load. It will take a little time, so you wait for it to load. I didn't want to open it and keep. I wanted to start from the scratch so that you see how you can start a new design. Okay, so now I don't want to use an existing template which I have created. I want to use a new I want to use a new uh, sheet so that you can see how to set up the Civil 3D workspace. So I will click on new. I'll click on new. Click on new. Okay. So when I click on new, what I'm going to do here is that I'm going to save this project in a particular location. So let's save the project. I will click, I will go to save as. Okay. Then I will locate a particular place I want to save this design. Locate. So let's come here. So let's come here. Then we can create a new folder. Can create a new folder. All highway design drawing. Design drawing. Okay, so we click on that. So we now click, now save this. We save this as a Sana design road design one. You can just use road design one, and you click on save. So that has been saved. So when you look at this menu tab, you see that the name of the road has been changed to Yesana Road 1 Design. Okay, so the next thing is for us to edit and set our Civil 3D workspace. So we have finished with step 1. So step 2 is to edit and set the Civil 3D workspace. So go back to Civil 3D. Now, once you have finished saving your work and give it a name, the next thing is for you to click on setting. You click on setting, and when you click on setting, come to the road name or the project name. When you click on it, you right click. So when you right click, you go to edit drawing setting. Edit drawing setting. Now, this is where you set the units of your drawing. So so by default, the unit here is in meter, and the angular unit here is in degree. Then we have the scale. So you can change the scale to whatever that you want. So we will allow it to remain in 1 is to 1,000. So the custom scale is 1,000. Then the next thing that you do is to set your datum. So you can see that Civil 3D is telling us here that under category that no datum, no projection. So now let's go back to a little note that we have here so that we can understand what a datum is. So what is a datum? A datum in survey is a reference point or a surface used as a starting point for measuring position on the Earth surface. It is used to define the location of point on the Earth in a consistent and standardized manner. Several different types of datum are used in surveying, including geoids, ellipsoids, and local datum. So a highway engineer should always find out the reference datum of his point and coordinate from the surveyor to help him choose the right referencing datum when embarking on highway design in Civil 3D. So you have to find out, this is very, very important, so that when you eventually import your point, you will not have a wrong coordinate or a wrong location of that road. So you have to find out from the surveyor which datum did he use. So for instance, now when the surveyor that did the survey of the road that we are going to design right now finish the surveying, we have to find out from him the datum that he used. So he told us that he used WGS 84 datum. WGS 84 datum. So that is what we are going to use. Now we also have UTM zone 32. UTM talking about the now the two commonly used datum include Nigeria, which correspond to Mina, UTM zone 32, and UTM WGS GS 84 datum. Now, so you can use any of these, but before you adopt any of these, you have to find out from your surveyor which of the datum did he use so that your your referencing point will be exact and correct. So we are going to use WGS 84 as a datum, and we will also look for a surveyor. We also look for a survey data that the surveyor used uh, UTM UTM as the datum. So we are making use of WGS 84 as the datum. So we go here. Now on that datum, we just scroll down. We scroll down. Okay, so this is the datum that we are going to use. UTM WGS 84 datum. So the moment you click on that, it will suggest the available coordinate system. The available coordinate system. I think by now you should know what the coordinate system is, so we don't need to go back into it now. So the coordinate system that correspond with our design information is, I'm going to select that coordinate system. I'm going to select that coordinate system because this coordinate system is based on our location. Our location is in the south. So let me look for it. Let me look for that. Let me look for that. You have to be very careful. And let me look for it. Zone. Uh, Okay. So now this is the one that corresponds with our location. This is the one that corresponds with our location. So you have to take note of this. So once you select the variable coordinate system, the coordinate system code will automatically appear. So the next thing is for you to click apply and you click OK. So you have successfully set set up your Civil 3D workspace. So the next thing that we are going to do is for us to import a point. Okay, in this case, you click on the prospect tab. You click on the prospect tab, then you click on point. So when you click on point, you right click on create. So this dialog box will come out. So you click on this point, import point. You click again on this. So it take you to a location. So you will now locate where you save the point information. So let me locate where I save that point information. So let me locate where I save it. Okay, I save it here. This is where I save it. So I click on it and I click on open. Now, if your survey data were properly arranged, it's going to tick this. You're going to have this right tick. But if it was wrongly saved, then you have an X tick. So in this case, it was rightly and everything is okay. So now remember that the point of arrangement was PENZD, talking about point, eastern, northern, elevation, and description. So you click on space delimited. So when you click on space delimited, you click on add point to point group. So when you click on that, you click on OK. Then you can close that. For you to see this point, you have to right click, go click on zoom, then click on zoom extend. So the point will just come out. Okay. Now, when you look at this, these are just points. There is no description. There is no point number. And there is no point number. So for us to bring out the description and the point number, what we need to do is we click on point group, right click, go to property. So when you click on property, click on all point. Now when you click on all point, now look at point label style. You see that it is set on none. So you select point elevation and description. Point elevation and description. So you apply. So when you apply, all the point information would come out. So you can see the 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 description, the point number, and every other information that you need. Okay, now we are going to draw the center line. We are going to draw the center line. But before we draw the center line, group we have to group or isolate the center line. We have to create a group for the center line or any other information that we want or we need. We have to group it. So that I don't want to miss the center line. So what I'm going to do now is that I'm going to group this and then isolate it and work on it. So for you to do that, you come under point group, right click, click on new. So you click on new. Then under name, you can type in center line. Center line. Okay, so when you type in center line, you come to include. You click on include. You come to with raw description margin. With raw description margin. So you click on that. Then you type C. Then you press shift and press asterisk. You press shift, then press asterisk. Then you come to point list. Now you see everything that has to do with C will appear. The challenge that we have here is that the surveyor did not specifically uh, arrange the center line the way it ought to be. He would have just uh, labeled the center line like CL separately without mixing it up with any other description. But however, we are going to manage this, no problem. So you click on apply and you click on OK. So for you to isolate the center line, what you need to do, you click on the point group. Just click this point. You click on center line. You right click. Then you come to click on select. When you click on select, you now type isolate. You type isolate and you press enter. Okay, so this has isolated every other features or description. So what you have here is center line, and it will be very easy for you to draw your center line. Okay, so we want to draw a center line. There are two ways of drawing the center line. Number one is you come to alignment creation tool. You come to alignment creation tool. You name the alignment. You name the alignment. You name the alignment. Then number two, you name the alignment. When you name the alignment, now you come to you name the alignment. When you name the alignment, a particular when you click and you set up your design criteria, and once you are done with that, you will a a dialog box will come out. I think we are going to demonstrate that later, but let's all start with using polyline to describe our center line. So we are going to make use of polyline for this one. Once we are done, we will also apply the same method. Now, when you are creating a center line, what you need to pay attention to is for you to pay attention to the road alignment, how the road look like. You have to pay attention. So if you check from here to this point, you see that it is straight. And when you check here, there is a curve. Then here there is a curve. Then you also look at this point, there is a straight line up to this point. And here there is also a curve. And here there is a curve. Then this point there is a curve. And this one there is a curve. And here there is a curve, and then a straight line. So with this, by the time you are able to look at how the road look like, then you'll be able to, create your horizontal alignment properly. Okay, so we pick our polyline, pick the polyline, and you look at the first point, you click on it. Now, when you are creating your center line, it does not necessarily mean that you have to click at every point. No, you don't have to click at every point. So what you need to do is to look for the base straight line. You look for the base straight line. So when I look at this, the base straight line is from here is from here to this point. So I click, I click here, I click this point, I click this point. Then I move again, I move again, I move again to where I have another point. Then I click. Okay, so we look for the next straight line. Look for the next straight line and we click. Now, while we are doing this, we are trying to avoid creating unnecessary curve. We are trying to avoid creating unnecessary curve. So this one also is straight up to this point, up to this point. Okay, so we now have this straight up to this. So we click here, then we click, we come to this point. So let's observe how. So we click here, then there is a curve at this. There is a curve. So we click this, then we move again. We move again. So there is a straight line that runs from here to this point. So you click this point. There is a curve somewhere here. So what we need to do here is to click this point, then we move again, we move again, we move to this point, then move to this. Okay, so move again, and this place is not all that straight, so let's see what we can do here. So we click here, then move again, move again, move again to this point, then we click here, click here also, then move straight again to where we have another curve. So we click there, then we have a curve at this point, then we move. So there is a curve here, there is a curve here, so we move, we click this point. So we move again, move again to this point, and finally we stop it at this. Okay, so at least this center line is just to guide us on the road alignment. So it does not necessarily mean that the road has to be on the exact position of this center line. It's just to guide us. Okay, so the next thing is just for us to create our road alignment. So you click on alignment. You click on alignment. So let me look at our, okay, importing and arranging of survey that, okay, coordinate. So the next thing, creating of horizontal alignment. Okay, that is what we are working on now. Okay, so when you want to create your horizontal alignment, you click on alignment. Now we are not going to make use of alignment creation tool, but we are going to make use of create alignment from objects. Create alignment from objects. So you click on create alignment from objects. You click on the polyline, click on the polyline, then you press enter. You press enter. Now, if you check this down, you see press enter to accept alignment direction or reverse. So we are going to accept the alignment direction. So we press enter again. Okay, so when you press say enter again, this create alignment from update dialog box will come up. So what you do is you put the name of the road. So this is, let's call this a year Sana road alignment. A year Sana road alignment. Okay, here's another road alignment. Okay, so the next thing we will do is to define our design criteria. Define our design criteria. So this road is actually a rural road, and we are going to design this road using a design speed of 60 kilometer per hour. 60 kilometer per hour because it is a rural road. It is a rural road. It's not a a trunk a road. So it's just a rural road. So we type in 60 60. So you click on use design base design base use criteria based design. Okay, now I have already imported this minimum radius table into this my Civil 3D. I think I will do a video to show us how to go about this. I'm going to use super elevation factor of 6. I'm going to use super elevation factor of 6. So you can get all these things from the Federal Highway Design Manual. So a transition lane table, we are going to use 2 lane. 2 lane. Okay. So when I have set up that, I will uncheck this. I will uncheck this and click OK. I will click OK. So the road alignment has been created, but you have not seen the changes. So what I'm going to do is to bring out the changes is to click on this center line, then right click, go to edit alignment label. Edit alignment label. Okay. So when I click on edit alignment label, what I will do is to add. Click on add major station. Click on add major station. So here I will change the major station to 25 because I asked the surveyor to survey the road using an interval of 25. So I'm going to edit this information. So I'll click on that. Then come to where under station, under text, I'm going to edit this text. You just highlight this. So when you highlight, you come to format. You come to format. Here you, whatever font size, font style that you want to use. I want to use area. Then I want to use black and white. So using black and white, I will bolden it. I will click OK. Then I will set the layer to white. Set the layer to white. The next thing is to work on the tick. The same thing also white. The same thing white. I will click on apply. I will click on OK. I'll click on apply. Click on apply. Click on OK. So you can see that the changes has actually come out. The changes has actually come out. Okay, so the next thing that we are going to do right now is for us to check our radius. If the radius has meet up the minimum requirement, So let's go to the design code. Okay, I think it's like I did something here. I did something here. Okay, maybe I didn't copy that out. I did not copy that out. Didn't copy that out. Okay, so let's go to the design code. So let's look at the minimum radius, horizontal radius, the minimum radius of the curve, the minimum radius of the curve, so that we can use that to check each of those curves if they are okay or not. Minimum radius for the curve. Minimum radius of the curve. Let's curve radius. Okay. Okay. Okay, fine. Minimum radius. Minimum radius. So we are using super elevation factor of 6, and we are using 60 design speed of 60. So under 6, the minimum radius is 123. That is the minimum radius, 123. 123. So we are going to use this as the minimum radius, 123. So for us to know if each of these curve has passed the minimum requirement, so what we need to do is to click on annotate, then come to where you have add label, click on alignment. From here you click on single segment. So I'm gonna okay. Okay, so as you can see, the radius here is 200, so it has passed the minimum requirement. So let me also check it here. Okay, this has also passed. This has also passed. So let's check here. Okay, now before we can actually know where those curves occur and how we can also rearrange them, there's something I want to do now. Let me add geometry point. So for you to add geometry point, so you click on the center line, come to edit alignment label, then click here, then click geometry point, click on add, click on OK. So I'm going to edit this also to what I want. Okay. So here under content, I'm going to highlight the content that is inside, then go to format, click on area, then change this to white, black and white. I want to bold it. It's okay. So I come to by layer, click on white. Then the next is the line. The line, I want to also make this line to be white. So I'll click on white. So the line has changed to white. Then the tick, I want to also make the tick to be white. So I click here and I click here and I click apply. I click OK. I click OK. I click apply and I click. Okay, so now these are the point area, the curve area. There is a curve at this point. There is a curve at this point. There is a curve at this point. So we can strengthen it. There's a curve at this point. So we can drag this. Now without this, I wouldn't have known that there is a curve at this point. So let me add curve label at that point. So let me add curve label. Okay. So the radius here is 2000. So we can remove this curve because it's just like a straight line. So we can remove this. We can remove this curve at this point. So how do we remove the curve? Because it's just like a straight line. To remove the curve, you click on it, then you click on geometry editor, then you click on delete PI. So you come to where you have then you press enter. So that curve will be deleted. Okay. So that curve will be deleted. Then the next one is this. The next one is this. So let's check this curve. Let's add curve information. Okay, so we still have 200 here. Still have 200. Okay, so here we also have curve. So let's see how we can work. Let's add the curve label. Okay, so the curve here is 78, which does not meet up the the minimum requirement. So we click on this, we drag this. As you are dragging, you observe, you drag again. Okay, so I think that is okay. That is okay. So we also need to add curve level here. Need to add curve level here. So this is just 42. So this does not also meet up the minimum. So we click here, we click here, we drag this down, we drag this curve down because we drag it down again. Okay, so we come here, we click here, we drag it. Okay, so what do we have? 42. We click again. So what do we have? This is 51. This is 51. So let me work on this place so that we can actually get what we want. So I'll click on this. This is 75. I will push this curve a bit and now push this. This is 93. This is 8C. So we have to work until you get. Okay. Okay, now instead of adjusting this, okay, I think let me use this method so that you will not make mistake. So let me use this method. Let me use this method. This is 93. So we are trying to see how we can adjust this so that at least we have minimum of because of this. So let's me see this. This is 88. Okay, I think what we are going to do, we are going to remove one curve. We're going to remove one curve. So you click on that and you click here. You click OK. So that curve has been removed. So we can still shift the center line of the road to where it ought to be. Okay. So let me now work on this curve. Let's work on this curve. Okay. Okay, so this is 140. This is 140. Okay. So that curve has met up the minimum requirement. So we move to the next curve. We move to the next curve. You have to make sure all your curves meet up with the minimum requirement before you proceed with your design. Okay, so this is 42. This is 42. So you click here, you drag, come here, you drag again. You are dragging, you are observing. Okay, so that one is okay. That one is okay. So we move to the next one. We move to the next one. We do the same thing here. So let's add the curve length. So the curve level. So here is 42. So we have to adjust it. So we adjust this 106. Adjust again, oh, fine. So that has given us the minimum requirement. So let's look at this and see how we can also work. So let's add the curve label here. This curve is just 42. This curve is 42. So we click here and see how we can adjust this. Let's see how we can adjust this curve. This curve is not moving. This is 76. This is 90 something. So it's not moving again. It's not moving again. So what will be the solution here? This is 1, 2, 3. This curve is 98. So this curve is not moving again at this point. It's not moving again at this point. So there are two options here. Either we delete this curve and now expand this. So let's try and see if when we delete this curve, if it will give us something reasonable. So let's delete this curve. We can delete this curve at this point here. Okay, so let's now move this road to here And now expand this curve. Expand the curve. Expand the curve. Expand this curve now. Expand this curve. So this is 1, 3. So this is another curve. This is another curve at this point. So let's work on this curve. Okay. So let's add the curve level to it. Okay. So I think this one is okay. 287. Okay. So we are done with that. So we move to the next curve. Here's another curve. So let's work on this. Also, let's add level for us to be sure. Okay, this curve is just 85. Just 85. So let's work on it. This is 112. So just adjust it a bit. Okay. So we are done with that. We are done with that. We are done with that. So let's still adjust the root so that we don't move completely away from the original alignment. Okay, so let's add curve to this. Let's add curve level to this. This one is just 42. So we click here, adjust it again. This is 99. Adjust it again. This will give us 143. 143. Okay, so from the look of things, this curve has to go. So we come here, we delete this curve. Okay, so when we delete that curve, we try to adjust this back. Okay. Then the same thing will also happen here. It's just 42. So we are going to adjust this curve to give us the minimum requirement. This is 97. Okay, so that one is okay. So we move to the next one. We add curve level to it. So the curve here is 42. So we have to adjust it. This is 96. Just again, fine. So we are almost done. So this curve, we don't need it. We don't need this curve here. Let's look at it. I think we have to remove one of these curve. We don't need this curve here, so we remove this. So we realign the road again. Then we can work on this one. We can work on this. Is 42. So we work. Okay, fine. Then the last, but not the least, is this one. Okay, this one is 42. So we work on it again. Okay, fine. So as you can see, all our curve has actually meets the design, the minimum design requirement. The minimum design requirement. So when you check all these curve, there is none that is below 123, which is the minimum requirement for design speed of 60 kilometer per hour. 60 kilometer per hour. So all these actually meet up with our design. So because we don't want each of the model to be too long, so we have to stop it here. So we are going to stop it here and we continue in module 2. So thank you. I believe that you have learned something today. Thank you and bye. See you in module 2.